Good morning, everybody. Today we're going to be talking about the scientific methods, setting up experiments, and all of that kind of stuff. What we're really getting into today is how do we do science? And so what we're going to be looking at are the components that make something a scientific project and how we can walk through a regular, consistent process to try to answer questions using something called the scientific method. So, without further ado, let's go ahead and get started. Do you ever have a question that you really wish you could get answered, and you just can't quite figure out how to get the answer? Well, science is all about answering questions. And so we're going to be answering a couple of questions here today to try to get a better idea for how we do science. But before we can even start doing science, or whatever you want to call it, we have to start with the question that we're trying to answer. Those questions can be what questions, why questions, or how questions, but we need to pick a single specific question that we're going to answer so that we can start walking through the process of the scientific method. So for my example today, I'm going to pick up two things. I got two different versions of hand sanitizer here. This one is the school hand sanitizer that they've given us in a large spray bottle. And this one is just a standard bottle of hand sanitizer that you can buy at the store. And my question is, which one of these two is the better hand sanitizer? So I'm going to go ahead and set up an experiment that helps me answer those questions. And so now that I've got my question, the next thing I'm going to do is I'm going to do some research. Maybe I'll look into what is in each one of those hand sanitizers. What are the ingredients? Things like that. And after I've done a little bit of research and I've determined nobody else has answered this question, then I can move on to my next phase. And this is the phase that a lot of us have learned in elementary school. We're going to form a hypothesis. A hypothesis is just an educated guess. It is something that we think is going to work out, but we haven't tested it yet and we haven't tried it yet. So we're going to go ahead and state an educated guess. And so for my educated guess, I'm going to guess that the school's hand sanitizer is going to clean my hands better than the store-bought hand sanitizer. Do I have a real reason for that? I think that the school's not terribly cheap and they probably got us the good stuff. That's really my only answer, but it's an educated guess. It's something that makes me think, all right, here's a good place to start with. Now, after we've done our hypothesizing and we think we've got a theoretical answer, now we can go ahead and run an experiment. And this is where we start setting things up like control variables and independent variables and dependent variables and things that I'm going to talk about in a moment. But to really get down to what the heart of the experiment is, we need to set it up where we've got one thing versus another thing. So I've got, again, my school hand sanitizer and my store hand sanitizer, and the experiment that I'm going to run is going to compare these two things because I want to see which one is more effective. Now, I've gone ahead and I've created my experiment, and let's say that I tested them both on a plate of bacteria and I found out that one of them killed the bacteria better than the other one. All right, now I've got stuff. I've got data that I can work with and observations. Now I'm going to write that down in some place. I'm going to write down what I saw. I'm going to write down maybe the amount of bacteria that died in each one of my experiments. And that's good. We should always be writing down our data. That's one of the most important parts. But we also have to analyze it. We should be looking at our data saying, does this make sense? Is there anything that might have screwed my numbers up so that they weren't accurate? That's analyzing the data. And then finally, at the end of this, you have to go back and see, does my data mean that my hypothesis is correct, or am I wrong? And you should never be afraid of being wrong in science. We just say that we're rejecting our hypothesis. We're saying this hypothesis, no, this is not a good idea. Maybe it was the school version that worked out. Maybe it wasn't. But either way, we're testing that hypothesis to see exactly what is happening and whether we were right or wrong. And finally, once we're done with that hypothesis, we're going to go ahead and kind of wrap this whole thing up in a conclusion. Now, that conclusion should address a couple of things. The first thing it should do is it should state plainly, was my hypothesis right or was it wrong? And remember, there's no problem with being wrong. The second thing you should do is talk about, are there any sources of error? Did you do anything that might have caused your experiment to give you bad data? And then finally, go back and answer the question you started with, which in my case was, is it the school hand sanitizer or the store hand sanitizer that cleans better? And that is how you work through the scientific method. Now, that's all well and good, but earlier I mentioned something called variables. We talked about independent, dependent, and control. So what are those? Variables. You've heard about them before, probably in a math class. You had X's and Y's and things like that, maybe Z's if you were really unfortunate. Variables in science serve a different purpose. In science, a variable is something that we know is going to affect an experiment. And so we're going to make sure that we're either controlling it, we're measuring it, or it is the thing that we are intentionally changing. And so variables control the quality of the data that we get out of our experiment, and in doing so, they really control how well we're able to answer our question and confirm whether our hypothesis was right or not. So let's go back to our other example. I've still got my bottle of school hand sanitizer and my bottle of store hand sanitizer. Now, if I'm designing an experiment about these two things, sure, I might take a petri dish of bacteria and squirt the petri dish with this one and see how well that kills it, and then take another petri dish of bacteria and squirt this in there and see how well that kills it. That's an okay experiment. It's not brilliant, but it's also not the worst. But there's variables there that we're controlling intentionally. So the thing that I'm making sure that I'm changing, the thing that I'm in control of, is which type of hand sanitizer I'm using. And so we call that an independent variable. The independent variable is the thing that we're controlling. Now, the thing that I'm going to be measuring, the amount of bacteria that's left in the dish after I'm done spraying it with either one of these, that's our control variable. That's something that we are measuring, and it's always going to respond to our independent variable, the type of solution that I'm using. Now, those are easy to identify, and they're really important for designing experiments, but there's something else that a lot of people don't take into account, and that's something called controlled variables. Controlled variables are things that we want to make sure that we are keeping the same so that our experiment is as accurate as possible. So one control variable might be the amount of bacteria in the petri dishes, or the amount of spray that I'm using with either one of those hand sanitizers. Those are things that I'm going to want to make sure stay the same no matter what experiment I'm running, because then I can look at my data and I can realize that it's accurate. And that's what we're really going for. We really want our data to be accurate. So now that we've designed our experiment, we've talked about variables, let's go ahead and talk about actually executing the experiment. All right, finally, we get to do our experiment. We've defined our variables, we've figured out what our hypothesis is, we've gone ahead and we're trying to answer the question. And in my example, I'm using the question, is hand sanitizer from the school or hand sanitizer from the store going to wind up being better? So I've thought about my independent variable, which type of hand sanitizer I'm using. I've thought about my dependent variable, the thing I'm going to measure, how much bacteria is in the petri dish when I'm done. And I've thought about things that I want to keep the same, like the amount of hand sanitizer that I'm using, or the amount of bacteria that we're starting with. So let's go ahead and actually do the experiment. First things first, make sure that you are paying attention to any possible safety issues. So for instance, if there was something that might damage my eyes, I would make sure that I'd have to wear some goggles for this. Now, you might also have gloves or masks or anything else, but don't ever skip on safety things. You can't redo an experiment if you hurt yourself in the process. So now I'm going to go ahead and I'm going to bring out my material. So I might have 2 different petri dishes with equal amounts of bacteria inside of them. So this would be part of my materials section of my report. I've got my school hand sanitizer, and I've got my store hand sanitizer, and the way I'm going to be measuring these things is I'm going to use 1 full press on each one of these handles as my way of making sure I'm deploying the same amount for each time. So I can go ahead and put my hand sanitizer in there, and my hand sanitizer in there. And if I was to mix these up and let them dry out, I could then measure and see how much bacteria is left over. And that would be data that I would put in a data table. Now, is one experiment enough? Maybe. Maybe it's not. Maybe you should run this experiment a couple times to see if you have any numbers that are giving you problems. After all, if I turned out to have messed up one of these and I only did it once, I'll never find out. Which is why most experiments require that you repeat the experiment multiple times before ending with a final answer. And those are the steps of doing the scientific method to answer a question. We go ahead, we start with our question, we decide our variables, we define our experiment, we report our data, and then we come to our conclusion. Was the school hand sanitizer more effective? Well, in this case, because I've done the experiment before, yes, the school hand sanitizer here is really effective. And from doing my research, I can tell you it's because it's got a higher alcohol content than the normal store-bought kind. So now I have an answer and I have an explanation. So hopefully this will help you with the experiments that you're going to be running. And good luck, because science can be a little tricky, but I know that you can do it. So, see you in class.